Hi guys, Mr. Mack here. I'm going to teach you how to do problem number 3 on our optimization worksheet. The problem goes like this. If you have 400 feet of fencing and you want to make an enclosure for all of your animals, okay, you want to keep them together, but we're going to make it rectangular and we're going to make sure that we have the barn as one of the sides, okay? So we'll need 3 sides of the rectangle. What dimensions of the enclosure will maximize the enclosure's area? Now, first of all, you got to realize, if you have a barn, if you have a barn as one of the sides, okay, then all we need is 400 feet of fencing for those 3. So I don't know. What kind of letters you guys want to use for this?
X and Y.
X and Y. Okay.
I like Q.
Yeah, X and Y.
E and pi.
You said I like you.
No, I said Q.
Oh, they said I like you. That's
Well,
nice.
that
like
too.
Use a nice letter.
Was it inappropriate? Sorry. Keep going. Keep rolling.
We'll keep it off
Keep rolling.
So anyway, we'll use X and Y, but the thing is we have 400 feet of fencing, 400 feet of fencing. So what equals 400? I'm just talking to the class. What? Yeah.
2x plus y.
Yeah. I got 2 X's and a Y that add up to 400, but I'm trying to maximize the area. This is a really good problem because I really want this to be as big as possible.
Does it matter if you do 2x plus y or 2y plus x?
No, it doesn't matter. But then if it was 2y plus x, you have to have your y's here and your x's here.
Picture, yeah.
Okay. Now, here's the thing about this too. Like, I only got 400 feet of fencing. I got an idea. Maybe like you're getting hired. Like, hey, come build my fence for me. I got 400 feet of fencing.
Okay.
What do you want? I want the maximum area possible. And you're like, I got this idea. I'm just gonna put all 400 feet of fencing like against the barn and like. Well, then there's no area, right? There's no area.
That's a good idea.
And then like the fence is red because it's covered with like the blood of the animals that you just like.
Well, that's
Belgians! Oh!
Anyways, so I'm pretty sure x should not be 0. X should not be 0. X should not be 0, but it certainly could be, right? But I don't want it to be. Now, careful. If y was 0, if you actually made this so long that y was pretty much approaching 0, what would both of these sides be if the whole fencing added up to 400?
200.
Yeah, like 200 each, exactly.
approximately.
So this is like almost 200 each. So x could be 200. We don't want it to be 200 because then you have no area that way. But at least I have like a little boundary. It's almost like I'm thinking that my area maximization is going to be forced between 0 and, I hope my answer is between 0 and 200. It kind of has to be. All right, so here we go. Let's do this. Area is equal to x times y. So here we ask these same questions. Oh no, I got 2 variables. Let's get rid of one of them. Okay, what could I do?
Substitution.
Yeah,
Solve for y.
I guess we have a choice, right? You could like y is 400 minus 2x, or x is 400 minus y all divided by 2, but it's probably cleaner to solve for y.
For sure.
This is nice, conversation. Let's just solve for y. So y is 400 minus 2x. So I'm just going to go, hey look, it's another one of these negative cubics. That's good. 400x minus 2x. No, it's a quadratic. That's even nicer. It's a negative quadratic.
Aww.
You know what? I don't even need calculus for this one. We're still going to use it though. But if a negative quadratic has zeros at 0 and 200, quadratics behave beautifully symmetrically. So what's our answer? 100. So I already know the answer is going to be 100. 100, 100, 100, 100.
Dose 100.
200. Okay? But I don't know that yet. All right, let's do it.
Oh, yeah, I did.
So I'm going to take my derivative. A prime is 400 minus 4x. Set that equal to 0. It looks to me like x is going to be 100. Okay, now, you were asking me just a minute ago, what do I have to do to prove it's a max? You could do the first derivative test with a sign chart, or you could just jump right to the second derivative test. But if you're testing around 100 and you take a number less than 100,
50.
50.
Oh, nice. Aw.
Classic.
Cute.
All right. So if I put a 50 into here, 400 minus 200 is positive. Number in between 100 and 200?
101.
101. So 400 minus 404, actually, who cares what it is, right? If it's a little bit bigger than there, that's going to be negative. Hey, look, I just proved it's a max. But again, like I said in class, it's like we don't really want to just assume let's do a sign chart. How beautiful and clean is the second derivative test? Because your second derivative is just -4. So no matter what, your first derivative of a at 100 is 0, and your second derivative at 100 is negative. So if you have a 0 slope on a negative concavity, it's got to be a max. Yay, we did it. Okay, now hold on. What are the dimensions?
100.
200.
Yeah, so now I go back here, and I realize, I'm going to draw it again, I don't want to go over that. I go back over here, I realize that that's 100, that's 100. I resubstitute or just think and realize the whole thing adds up to 400. So my max area is actually 200, 100, 20,000. 20,000, what
It
is
just
my
wants the dimensions.
Yeah.
dimensions that give me it?
So
All
100
right, so my dimensions are 100 by 200, which just for kicks, because the farmer wants to know how much square footage he needs for his fertilizer or whatever. That's going to be 20,000 square, what was it, feet?
Yes.
Yeah.
Square feet. And that's how to do number 3.
Yay.
Actually, these problems are pretty cute. They're not bad at all. Yeah.